Okay, the last video I did was this one, which was the turbocharger boost limit or boost limiting map, and I mentioned that we've got a map and we've also got a single value to stop things getting out of control. And I also mentioned in passing that we've got this one here, which is the N75 map, and I think I probably warned people in a previous video, don't fiddle with this map. Okay, now this map is for the actual turbocharger actuation. So this is the map that's actually controlling what the turbocharger is doing. And that's why you don't want to fiddle with it. Right, now let's open it. Right, now if you remember back to when I looked at this map in the past, we've got revs per minute, we've got the amount of fuel that will be injected. And so these two are pretty much tied together as usual, aren't they? Because if I inject more fuel, I'll get more revs. So it's almost as if I'm looking at the same thing mirrored. I inject a lot more fuel, I get a lot more revs, and a hell of a lot more fuel, a hell of a lot more revs. And we've already noticed that somewhere around about 52-ish is probably about the peak, but it runs up to 58, and we've seen 58 before on other maps. Now let's have a look at what's going on. These values here, you could argue, are the amount of turbocharger effort that you can have. They are a percentage, and they go from 100 to 0, except that they rarely ever do. Most files that you will look at, the maximum here will be somewhere around 80 to 95. You don't often see 100. It does happen, but if you see figures at the beginning here for about 80, 85, 90, 95, that's fairly normal. And if you see figures down this end and the small end at 25 or 20, again, that is fairly normal. If you see large numbers all over the place over here, then somebody has fiddled with the map, and that is a nightmare, because the designers pretty much calculated all of these values, and they calculated these values because that calculation is based on the fact that the turbocharger will be actuated by an actuator, and it's got an actuating rod. And the actuating rod can have variable length. Now, the person who designed this map is assuming that the actuator rod is the length they've been told it will be and will give the amount of actuation that they are expecting. So they are assuming that when this puts out its figure of 80 or 80%, they are assuming that the turbocharger rod will give that much actuation. But of course, if someone has changed the length of that rod, this is now not reading properly, which is why you shouldn't fiddle with the rod. And of course, if the rod has been left alone, but someone has fiddled with this map, they don't match again, do they? So again, it's a good reason not to fiddle with the map. So there are lots of reasons why you should never touch this map unless you've got good reason to. You've learnt enough to think that you can make a meaningful change, or you just want to make changes and gamble that you won't damage anything. But that's entirely up to you. But for God's sake, don't play around with this map on someone else's car, because you will end up upsetting them a great deal, and you may find you can't get back to where you wanted to be, especially if you fiddled with this map and the length of the rod of the actuator. So be wary of going down that road, especially if you're a beginner. Right, okay, now why is this not 100%? Well, like I said, it's very rarely 100%. It's nearly always somewhere around about 80 to 90, maybe 95. You might as well call it 100%. Basically, what it's saying is that at any of these values, the turbocharger should be set at the maximum position. So the vanes or nozzles, whatever you want to call them, will be set at the maximum value to give the maximum boost. Now, don't confuse give maximum boost with maximum boost. When you say the turbocharger is set to give maximum boost, what it will actually be giving depends on the revs. So the words give maximum boost don't mean maximum boost. Maximum boost you can get under any circumstances. So here we've got the turbocharger, then it's set to give maximum boost. And look at this, we're down at idle. So in other words, when you turn the engine on, this map instantly sets the turbocharger to give maximum boost. The vanes are in a position that gives maximum boost. Now that would be fine, but of course as the revs per minute rose, the boost would just go up and 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 up, and eventually something would break. Now if this was a turbocharger with a wastegate, the wastegate would open so something wouldn't break, because we would open the wastegate and we would dump the pressure we don't want, and that wastegate would be fixed at, let's say, 2,300 millibars, because that's a figure we've seen here, and we would get a peak and a constant flow of 2,300. Now because this is a VINT or VNT or variable nozzle turbo, we don't get that. What we get is a steady closing of the nozzles or vanes, or opening, depending on which way you look at it. Some people call it opening, some people call it closing. Let's just stick with the numbers and not worry about opening or closing. So while we've got 80, we've now got the ability to get maximum boost. So that's what we're trying to get. And because the revs are rising and we don't want to overboost, what we're actually going to do is the ability to request boost is reducing. So we're not requesting less boost, it's the ability to request boost that's being reduced. So we are steadily reducing the amount we're requesting, in the sense that we want boost to keep rising, but we don't want it to rise out of control. So what we're doing is we are asking for a little bit more and a little bit more and a little bit more and a little bit more. But effectively we're asking for more each time, but less of more. So if we were asking for 80%, let's say, last time, next time we're going to ask for, say, 72. Then we might ask for 62, and then 59, and then 55. Which is why once we get to maximum injection and top speed, and let's assume that, like the designers have, that top speed is about 4,000, which is, let's say, we'll agree that's about reasonable. Once we get to about this area, we've got about 25%. Now that can be very confusing, because that means that we've now got 25% of what we started with, so a quarter of what we started with. But what we're saying here is that we might have needed 80% to get full boost originally at low revs, but now we're on maximum revs. 25% is enough for maximum boost. So if these numbers were any higher than 25%, our maximum boost would be over the limit that the limiter allows, and we'd be in trouble. Because all that would happen is we'd be constantly flagging faults and dropping into limp mode. And this is where people come unstuck when they fiddle with this map. People often fiddle with this map because they just think, well, if I make these numbers higher, I must get more boost. But if you want to alter boost, what you do is you alter the boost map and you alter the boost limiting map. You don't play around with this map, because there isn't any need to play around with this map to get reasonable changes. So generally speaking, you don't need to fiddle with this map. So if you do, either do it under the guidance of somebody, or do it so that you're actually making changes that you are testing. So you're just making a few changes, checking the car to see what it's like. But do not make sudden great changes to it and then drive the car, because you run the risk of either dropping straight into limp mode or damaging the turbocharger. And so you don't want to go down that road. Right, I'll just close that one off then. Right, and I'll stop there.